Okay, welcome back, kiddos. Now we are starting unit number 8. It's our final unit of the semester. So today we're going to talk about similar polygons. Okay, so our essential question we're going to be able to answer at the end of the day to ourselves is, how are similar polygons related? Okay, so let's talk about similar. Okay, you know what the word similar means in general, that something is like something, but specifically similar in geometry means um, similar means the same shape but a different size. Okay, same shape but different size, because we remember congruent is a little different. Congruent means same shape, and then what about the size? It's the same size. Okay, so that's the difference between congruent and similar. So that's what we're talking about today. Similar is the same shape but a different size. Okay, that's the main thing. All right, so let's keep that in mind. Also, the symbols. Okay, so congruent, remember, is going to be like the equal sign, except for it has that above it. Okay, so similar is just going to use, let's get that out of the way. Similar uses that symbol right there. Okay, so that's our symbol. All right, so for similar triangles, the symbol is, as we said, like that. All three corresponding angle pairs are going to be congruent. Okay, so all the angles are going to be congruent. Okay, and then all the corresponding sides are not going to be congruent, which would be the same size. They're going to be proportional. Okay, so this is like when we do dilations. Okay, so it's either a bigger or smaller version of something. Okay, so we remember the K was called the scale factor. And that tells us how much bigger or smaller the triangle is, right? We talked about it with dilations. In this, we remember we did that scale factor is new over original, but we talked about it being K equals new over old. Okay, so that's the main thing that we're going to keep in mind on our scale factor is new over old. All right, so let's get right into some practice. Okay, so remember that similar triangles are proportional. Okay, so in this diagram it says this triangle RST. Okay, so we see this right over here is RST is similar to XYZ. Okay, so this means, right? That means similar, and we know that means same size, the same shape, but a different size. Right? And that's what we want to recognize. These are both the same shape. This is just a bigger version of this. All right, so list all pairs of congruent angles. Okay, so which angles are congruent to each other? Okay, well, we know that if we see over here, we see it might be turned around, but we recognize that this is the largest side, that's a medium, that's a small, that's the largest, medium, and small. So it's configured the same way. So the angles that are congruent, angle T would be congruent with angle Z. Right? Angle T is congruent with angle Z, right? And then let's do the other ones, angle R and angle S. All right, so angle R is congruent with which one? Angle X, right? Angle S is congruent with which one? Angle Y, right? It's congruent with angle Y. Okay, so all the angles are going to be congruent. So I could say like this one, I could put one arc on that one, I could put two arcs on that one. Those are congruent, and I can put three arcs on that one and then three arcs on that one. That would show what I have right over here. Okay, then we said the angles are congruent, right? But the sides are proportional. Okay, so write the ratio of the corresponding sides in the statement of proportionality. So if they're all proportional, that means the ratio of the triangle to the other are equal. So I could say, for instance, RT, right, this side, I could say RT over RT over XZ, right? The proportion of this to this is going to be equal to the proportion of this side to this side. So ST over ZY. And that's also going to be proportional to, now we started with this one first, so we got to start with that one. All right, so then RS is proportional to XY. Okay, so all those sides are proportional, and so those ratios are proportional as well. So we'll talk about that, how we can set that up. But as long as we set it up correctly, with starting with the correct one on top and the correct one on bottom, and correspond, then they're always going to be proportional. Okay, so now find the scale factor. Okay, well, we said the scale factor is K is new over old, right? And it says it goes from RST to this one. So it goes from this one to this one. So this one's going to be the new one, right? So it's going to be 15 over 25, right? So that could be 15 over 25, which reduces into 3 over 5. So that's our scale factor. Okay, so we remember it's just new over old. And I could actually done any of these. I could have done 12 over 20, right? That also equals 3 over 5. Okay, so any of those ratios would have been equal to the same. All right, so hopefully that's enough information to get right into some delta math practice. So let's check it out. It says quadrilateral CDEF, so this one right here, is similar, okay, to the quadrilateral of this one, right? So that means it's proportional. It's just a different size, so it's proportional. Okay, so find the measurements of HI. Okay, so we want to find HI right here. Okay, well, what do we know? If they are similar, then we can set up a ratio. So here's what we're going to do. We're going to start with a two fractions. Okay, fraction over fraction. So we want to find this, right? So let's label that as X. Okay, so let's just go ahead and start with our X, right? Now, X corresponds with 6, right? So I'm going to put 6 right over here, because I'm going to have this one's going to be this triangle right over here. This one's going to be this one. All right, so now since I started with this one, I'm going to start with this number right here, 21.6. Okay, so this was this over that, right? This over that, so it's going to be 6 over 8, right? So now all I have to do is cross multiply. Okay, so that's the beauty when we have a fraction over a fraction, we're going to cross multiply. So you might remember this from your earlier classes. I think we talked about it too. We're going to do this times this, okay, is equal to this times this. Okay, so I'm going to start with the red ones first because I like starting with my variables first. So x times 8 is going to be 8x, right? Okay, it's equal to this times this. So if you put that in your calculator, 6 times 21.6, you're going to get 129.6, right? So then all we have to do is divide, right? So we take a gross looking problem. If we just cross multiply, it makes it quite easy. So we divide that by 8, divide that by 8, cancels out. X is going to be approximately 16.2. Okay, so it's as simple as that. Now what if I set it up a little bit differently? Okay, so say if I said X, right, and I'm going to say X over here, but I'm going to put the 6 underneath. Okay, so as long as I stay consistent, so I'm going to start over here and I'm going to put this one underneath it. That means I would start with this one up here, 21.6, right? And then I would have 8 underneath it, right? Well, what happens if I do that? 8 times x is 8x, right? 6 times this is 129.6. I divide both sides by 8. Okay, x is going to still be equal to that. Okay, so either way, I still get the same answer. Okay, so as long as we set it up correctly, we're going to get the same answer. All right, so let's go ahead and look at a next example. See if you can do this one on your own. All right, so it says triangle TUV is similar to this one. Okay, so we know that they are proportional, so we can set up a proportion to find the answer. Okay, so it says find the measure of side YW. So YW is going to be this one right over here, right? So we want to find that one, so let's label that with the X, right? We're going to label something we don't know as X. So let's set up a proportion. So I know I'm going to have to find X, so let's start with that. X, this one is corresponding with 5.4, right? So let me put that underneath, 5.4. Okay, so I'm just going to do both of those sides underneath it on this one. So this to this, the proportion of that to that, is going to be, say I'm going to use the 12 and the 3. What would go on top over here? Well, since I started with the x, I'm going to start with the 12, right? And then the 3. Okay, so now let me just cross multiply. Okay, so 3 times x gives me 3x. Okay, then I'm going to say 12 times 5.4. If I put that in calculator, that's going to give me 64.8. Okay, so then I just divide by 3, divide by 3. X equals 21.6. And that's my answer. Okay, but what if I set it up differently, right? What if I said x right there, but instead of doing x over 5.4, I said x over 12. Okay, that would be proportional to what? What would I put over here? If I put x over here, that would mean up here would be 5.4, right? Okay, good. So then if I put 5.4 there, right, if I said x and then 5.4 and I said 12, what would go here? That would be 3, right? So then if we did that, 3 times x would give us 3x, right? 12 times 5.4 would give us that 64.8, right? We still divide both sides by 3. X would still be equal to 21.6. So it doesn't matter. As long as we do the math correctly, we're going to get the same answer, right? As we've discussed and as we should expect. All right, so go ahead and do the delta math practice now before we go on to the other side. Pause the video now, please. All right, so hopefully you paused the video and did those. So now let's step it up. Let's do these next examples. Okay, so it says if ST is equal to 65, so that's some information. So I'm going to put that there. ST is 65. TR is 40. Okay, that's 40. WU is 16. WU is 16. So remember, you could be drawing on your video screen whenever you have these come up. You don't have to necessarily draw them back down. Find the length of VW. VW. All right, so that's what we're trying to find. Is that right there? All right, so round your answer to the nearest tenth. Okay, so let's see. What do we know about these? We need to see, are they similar? Okay, well, we would say that the angles are congruent, right, or the same. So let's check it out. We got 45, we got 45, we got 97, we got 97, we got 38, 38. So yes, it is similar. So that means we can set up a proportion to solve. Okay. All right, so we want to find out that, right? So that's going to be x, and that corresponds with what? Is it 40? Let's look. X is in between 38 and 45, right? So between 38 and 45 is actually 65. Right? So we're going to say x is proportional to 65. Okay, so since we started with this one, we're going to start with this one right here. So we're going to say 16, right, is proportional to, so that's between 45 and 97. So between 45 and 97 is 40. Okay, so all we have to do is just make sure we match it up the same way. So now let's cross multiply, right? So x times 40 gives us 40x, right, equals, then 65 times 16, that's going to give us 1040. Okay, we divide both sides by 40. Cancels out, x equals 26. Okay, so once we determine that they were similar, then we can set up our proportions. All right, see if you can get this next one on your own. All right, SQ is 75. SQ, let's see, that's 75. Okay, QR is 58. QR is 58. SR is 56. SR is 56. TU is 29. TU is 29. VU is 28. VU is 28. All right, so this one's stepping it up a little bit. It says find the perimeter of TUV. And remember, the perimeter is add all the sides, right? So we need to find out all the sides of this. So we got to find out this side. We know this one and this one. We got to find out that one. So let's set up it says, let's see, we need to see, are they similar? Okay, that's the only way we can find out. So let's check. We got 50 degrees over here, 50 degrees, 48, 48, 82, 82. So yes, they are similar. Okay, so since they are similar, that means we can set up our proportions to solve this. Okay, so we know that's x, right, is what we want to find. So let's figure out which side corresponds with x. Pause the video and see if you can find out. Okay, well, it's between 50 and 48. So between 50 and 48 is 75. So I'm going to say x to 75. Okay, it doesn't really matter. I could have put 75 over there as long as I'm staying consistent, right? So x to 75 is, I can pick any of these. So let me just say, let's use the 28. Okay, so 28. That's in between 50 and 82, right? So between 50 and 82 is 56. Okay, so now let's just do our cross multiplication. All right, so x times 56, we know it's 56x. All right, 75 times 28. If you put that in your calculator quickly, you'll get to 2100. All right, so we divide both sides by 56. Cancels, x equals 37.5. Okay, but we're not done yet. Okay, so we don't want to find just x, right? We need to find the perimeter. So we got to add this plus that, right? The perimeter is going to be equal to 37.5 plus 28 plus 29, right? So that means that perimeter is going to be equal to 94.5. If we put that in our calculator. All right, so remember we could have set that up differently, right? We could have said it was x over 28 is equal to x over 28 would be equal to 75 over 56, right? We could have still done it that way, and we still would have come up with the same answer. All right, so as long as we set it up correctly, we would still get that same answer. All right, so let's go ahead and take a look at our next selection. So actually, go and pause the video and do these in Delta Math. Alright, so now let's get back to our toughest stuff. Now we're putting it all together. Alright, so this is like in a real world example. Alright, and rather than just a math problem. So it says Nicole is 1.55 meters tall. Okay, so you see Nicole here, that's how tall she is. At 2 o'clock, she measures the length of a tree shadow to be 30.5 meters. Okay, so this is the shadow right over here. Okay, so this is the important math information. Okay, she stands 25.6 meters away from the tree. So that's the base of the tree. That's where she's standing. Okay, so the tip of the shadow meets the tip of the tree shadow. Okay, so the right over there. Okay, so the tip of her shadow. Okay, right. So that shadow meets right over there at the same. Okay, so that means it's on this same line. Okay, find the height of the tree to the nearest hundredth. Okay, so a couple things. Hundredth means, okay, this is going to be the 10th, right? So this is going to be the 100th. Okay, so the 100th place is the second place. Okay, so let's go and check it out. So if we want to find this is what we're trying to find, right? We're trying to find the height of the tree. So let's think about this. We actually have two similar triangles, right? If we make a triangle like this, think about it like this. This is one triangle. This is one triangle, right? And then this one is another triangle, right? The difference is they're just two different versions of the same one, right? We got two that are similar. Okay, so since they're similar, we can set up a proportion to find out that value, right? So let's go ahead and draw it right over here first. So on this one, we know this is 1.55, and then let's see, how much is this? This red one. Well, if the whole thing is 30.05, right? 30.05. If we subtract this much, then that will be what's left over there, right? So we'll subtract 25.6. If we do that, we get 4.45. So that's how much this is, right? 4.45. That's how much that is, okay? So, so this height right here is actually that triangle. So 4.45, right? So that's 4.45. All right, so now the big one, right? So the big one, the whole thing is 30.05. Okay, so it's a little tricky, but we got to just use our information correctly. So 30.05, and what we're trying to find is x right there. All right, so now that we have it all set up, now all we got to do is set up our proportions, right? So I can say x is proportional to this, right? So x over 30.05 is proportional to what would go up top, this or this. Well, since I used x over there, then I'm going to use 1.55 up top. 1.55, and then on the bottom, corresponding with that is 4.45. So once I set it up, I just do my cross multiplication, right? X times 4.45 is 4.45x equals, okay, then this times this is going to give us a crazy number. And so then we're just going to divide by that 4.45. And so we get x is approximately 10.46685, right? Let's see, what was that number first? We had 1.55 times that would give us 22. Let's write this in. It would give us 22 point. What was that? 8625, right? Then we would have divided that by 4.45. All right, so we said that we wanted to the 100th place, right? So we want to write down 5 digits. Since we need 2, we're going to add 3 more, okay, just so we don't get it wrong. So since we need to have, we know our answer is going to be x is approximately 10.4, and then we think about that 6. Do we keep the 6 or do we raise it? Well, this 6 tells us to raise that 6 to a 7. Okay, so that's how that works. All right, so that's our answer. Let's go ahead and highlight our answer right over there too, so we know. Okay, highlight our answer. Highlight our answer. All right, so now let's go and move along. Let's try to see if you can get this one on your own. Okay, I know it's got a lot of reading in it, but I know you can do this. All right, so it says for a project in this geometry class, David uses a mirror, right? So a mirror on the ground to measure the height of the school's goalpost. Okay, so that's the goalpost right there. All right, so he wants to measure that height. Okay, so if that's what he wants to measure, that's going to be x. Okay, he walks a distance of 14.75 meters from the goalpost. Okay, so go from here. He walks that much. Okay. Then he places a mirror flat on the ground marked with an X at the center. Okay, he then steps back 1.45 meters the other way until he can see the top of the goalpost clearly marked in the X. So what he's doing is he's looking down, and when he looks right there, he knows he can see that top of that goalpost. Okay, so by doing that, he's created similar triangles. Okay, because this is going to be one triangle. Okay, and then this will be the other triangle. Okay, and then there's 2 different triangles, 2 different versions of the same triangle. So, since they're similar, we know we can set up a proportion to solve for those. Alright, so let's just set it up. So if we're trying to find that, which is x, right? So we're going to say x is corresponding with what? Which number over here? Well, x corresponds with 1.55, right? So let's just put that right underneath it. Okay, so then what am I going to have over here? Am I going to have this or this? Well, since I started with this one on top, I need to have this one on top too. So I need to have 14.75 right there. Okay, and then that corresponds with 1.45. Okay, so as long as we just set it up correctly, all we got to do is just do our cross multiplication. So we got 1.45x equals, okay, and that times that gives us a pretty gross number of like 15.76. We know we're going to the 100th, so that's 2 digits, so let's write down 5. 76724. Okay, so then we're just going to divide by that 1.45. It's always our last step, so x is approximately, oh, whoa, I'm sorry, what did we get? Alright, let's type it in. 1.55 times 14.75 is 22.8625. Alright, so let's back this up. 22.8625. Then when we divide that by that 1.45, we're going to get our final answer of that 15 point, and let's go ahead and write down those 5 digits like we talked about. So 15.76 724. Since we only want 2, right? So we know it's going to be 15.7, and then we look to this 7 to tell us what to do with that 6, right? So that means we're going to raise it. So it's going to be approximately 15.77. And that is our answer. Okay, so just remember on hundredths, that means we have 2 digits. Okay, so all we have to do is just set up our proportion the correct way. As long as we set up the correct way, all we do is just cross multiply. Alright, so let's do our final practice. If you have any questions, please let me know.